In this problem, I have a 50 kilogram crate that starts at rest, okay, and a force P is applied to it as shown at a 30-degree angle. Okay, it achieves a velocity of 4 meters per second at a distance of 5 meters. So after it travels 5 meters, it's going 4 meters per second. Okay, and I want to figure out what this P is, knowing that the coefficient of kinetic friction is 0.3 on the ground. So the first step in any one of these problems is to draw a free body diagram. So that's what I've got right here. Okay, so I've got my applied force P that I don't know. I have the weight of my object, which is the mass times the gravity. I have a normal force, that's what's keeping it, on the surface, and then I have a friction force that opposes motion, which is equal to the coefficient of kinetic friction times that normal force. Okay, so my two unknowns here are my normal force and my applied force P. Okay, so two unknowns, I have two equations. Okay. That'll be some of the forces in the x and the y. Now, in order to apply that, I have to figure out what that acceleration is. In order to apply the Newton's second law equation, I need that acceleration. So the first thing I need to do is I recognize that if I apply a constant force, I'm going to get a constant acceleration. Okay, I know the velocity at a position, so I use my constant acceleration equation that relates velocity and displacement. And so again, my final velocity is 4 meters per second. My initial is 0. So I take 2 times the acceleration I'm trying to find times 5, which is the displacement. So my acceleration is 1.6 meters per second squared. Okay, and again, I need that acceleration so that I can apply Newton's second law, which is force equals mass times acceleration. And I get that using the constant acceleration equations. Now, I sum the force in the y direction. This is actually going to help me solve for my normal force, which I don't really care what it is, but I need to know it in order to find the applied force P. So I sum the forces in the y direction. I got N, and then I have P sine 30, the vertical component of P, and then I have the weight, which is minus mg, or 50 times 9.8, and that equals mass times the acceleration in the y direction. And this crate does not accelerate vertically, it only accelerates horizontally, so the acceleration in the y direction is actually 0. So I get this relationship for n as a function of P. Again, it's related to both the weight as well as the y component, the vertical component of my applied force P. Okay, again, there's no acceleration vertically, so the acceleration equals 0. Now I can sum the forces in the x direction. Okay, so I have P cosine 30, that's the horizontal P, and then I have my negative friction force, which is 0.3 times N. Well, N is 490.5 minus 0.5 P, that's what I put down there. Okay, so those are my two forces in the x direction. Again, P cosine 30, friction force going in the opposite direction. And that equals the mass times the acceleration in the x direction, which I found initially to be 1.6 meters per second squared. Okay, so the only the only unknown in this equation I don't know is P, so I can just do algebra and find P is 224. Okay, that's the force that I need in order for the crate to move with 1.6 acceleration, which is what it needs to do in order to be going 4 meters per second after 5 meters. So again, free body diagram, sum the forces in the x, sum the forces in the y, figure out what you know about acceleration, and solve the problem.